A very good morning, my dear students. Welcome to the another session, the continuation for the collisions topic. Now, we are starting with one-dimensional inelastic collisions. One-dimensional inelastic collisions. And these inelastic collisions, there are two types we had already discussed. Number one is a semi-inelastic collisions. Semi-inelastic collisions. And the second one is perfectly inelastic collisions. Perfectly inelastic collisions. And previously we have discussed about the elastic collisions, my dear students. Previously our discussion was elastic collisions, and I had told you already there is a physical quantity called E, coefficient of restitution, and this coefficient of restitution will tell us about the nature of the collision. For example, elastic collisions ge the coefficient of restitution will be 1 irutte. And perfectly inelastic collisions ge coefficient of restitution will be 0. And this semi-inelastic collisions ge, so coefficient of restitution will be between 0 and 1. Careful observe ಮಾಡಬೇಕು. Alright. Now, coming back to the concept of inelastic collisions. Inelastic collision andre ಒಂದೇ ಒಂದು ಪಾಯಿಂಟ್ ನೆನಪಿಟ್ಕೋಬೇಕು, there is a loss of kinetic energy takes place during the collision. The loss of kinetic energy andre, so initial kinetic energy minus a final kinetic energy. So that's what the loss of kinetic energy. Change in kinetic energy is different and the loss in kinetic energy is different. Loss andre initial minus final amma. Alright? So this loss of kinetic energy will be there in inelastic collisions, whereas in this elastic collisions, so the loss of kinetic energy will be 0 because total kinetic energy is conserved in elastic collisions. Okay? Clear? Continue. Let's continue. So our concept, our topic of interest now is inelastic collisions. So in other type of collisions, here also the same. So there is a body of mass m1 moving with the initial velocity u1, and there is a body of mass m2 moving with the initial velocity u2, and this is the before collision situation. And after the collision, a body of mass m1 moving with a velocity v1, and there is a body of mass m2 and the e body ne after the collision moving with the velocity v2. Okay, here I can use the law of conservation of linear momentum because linear momentum is conserved in every type of the collision, my dear students. And the energy is also conserved. I am talking about the total energy is also conserved in any type of the collision. Right? But kinetic energy will be conserved in only some types of collision, and that is the inelastic collision. In both semi-inelastic and perfectly inelastic, there is the kinetic energy conservation will not take place. Kinetic energy will be conserved in only elastic collisions. Okay. Now, here, according to the law of conservation of linear momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, and let it be equation number 1. Right? And there is initial kinetic energy here, initial kinetic energy of the system. So initial kinetic energy is equal to half m1 u1 square plus half m2 u2 square, and there is a final kinetic energy of the system, my dear students, half m1 v1 square plus half m2 v2 square, and these two are not equal. These two are not at all equal. When these two are equal, that is what the elastic collisions. ಈಗ these two values will never be equal. When they are not equal, so there is a loss of kinetic energy takes place, which is not equal to 0, my dear students. Now look at the situation here. Look at the situation. Everybody should see. We have final velocity expressions after the collision. We have the final velocity expressions after the collision in inelastic collisions, right? Look at here. Here also we have two terms. Any term you take it, the denominator is m1 plus m2. Here also two terms, m1 plus m2, and this is a m1 plus m2. And this is v1, and this will be u1, and this is u2, and here also it is v2, and this is u2, and it is u1. Observe everybody. So what we have written already, listen, it is u1 andre it is m1 minus m2 anta we have written. Here also the same, it is u2 andre m2 minus m1 anta ನಾವು ಬರೆದಿದ್ವಿ. And here it is a 2m2, and this is 2m1. Sir, you wrote the final velocity expressions for elastic collisions, sir, but we are discussing inelastic collisions. This is your question. I'll change this equation into inelastic collisions. Final velocity is really this final velocity ನಿಮಗೆ expression ಬೇಕಂದ್ರೆ ಈಗ ಯಾವ ತರ ಈ equation change ಆಗುತ್ತೆ ಅಂತ ನೋಡ್ರಿ. Listen everyone. And here the e will come and add here. Simple. The e will come here. And here instead of 2, so that will be 1 plus e anta barutte. Here also instead of 2, that's 1 plus e anta barutte. That's it. So this is the final velocities after the collision in inelastic collision, my dear students, which is semi-inelastic. It's not perfectly inelastic. Semi-inelastic, the E value, coefficient of restitution value is 2 anta nam gottilla. So that lies between 0 and 1. I cannot say 0.5, or I cannot say 0.2 also. So as we don't know the exact E value for this semi-inelastic collision, we will keep it as E only. This is what the important expression for the final velocities after the collision in semi-inelastic collision. Alright? Clear? Eager. So if you remember the elastic collision final velocities formula, it is itane. For elastic collision, just now I told E is equal to 1. E is equal to 1 substitute ಮಾಡಿ ಅಲ್ಲಿ. E is equal to 1 substitute ಮಾಡ್ರಿ ಅಲ್ಲಿ. So E is 1 ಅಂದ್ರೆ 1 plus 1 ಅಂದ್ರೆ 2m2. Yes. Here E 1 substitute ಮಾಡಿದ್ರೆ m1 minus m2. Yes, that's what in elastic collision we discussed. Coming back to this V2. And E value 1 tan elastic collision ಅಲ್ಲಿ. Elastic collision ಅಲ್ಲಿ E value is 1. And substitute 1 here, 1 plus 1 will become 2, right? So 2m1 u1 by m1 plus m2, and here E value 1 tane elastic collision alli. A 1 substitute madri illi m2 minus m1 by m1 plus m2 into u2 barutte. Understand everyone? And this is the concept of inelastic collisions. Illi ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ ನಾವಂದ್ರೆ ಇಲ್ಲಿ ಲಿಸನ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ ಐ ಆಮ್ ಟೆಲ್ಲಿಂಗ್ ಯು ಮೈ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್. ಸೊ ದ ಇಂಪಾರ್ಟೆಂಟ್ ಕೇಸ್ ಏನಂದ್ರೆ m1 is equal to m2 is equal to m, and the second body is at rest, my dear students. Second body is at rest. ಈ ಕೇಸ್ ಅಲ್ಲಿ what happened to the final velocities after the collision? Let's see, ನೋಡೋಣ. So v1 is equal to u2 0 ಅಂತ ಕೊಟ್ಟಿದ್ರು. ಅಂದ್ರೆ this term will become 0, and here also this term will become 0. Half of the headache is removed. Alva? Half of the headache is removed. Okay, so V1 is equal to, this is left. So that I can write it as m common ಮಾಡಿದ್ರೆ ಇದು 1 minus e ಇರುತ್ತೆ, m plus m is 2m into u1 ಅಂತ expression ಬಂತು ನಮಗೆ. And here v2 is equal to ಎಷ್ಟಮ್ಮ? v2 ಇದು 0 ಆಗಿದೆ because second body is at rest. ಇದೇನು m into 1 plus e divided by 2m into u1. So in the m cancel and here also m cancel. Right? So what I can write v1 by v2 if I want to write it. Notary. So 1 minus e into u1 by 2 divided by 1 plus e into u1 by 2. u1 by 2, u1 by 2 cancel. And very, 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 very important expression we have got. When both the masses are identical, and their final velocity, and the second body is at rest. Understand? So this is the body of mass m and it is the body of mass m, and this is the body is at rest. Avaga ee v1 v2 enagutte andre the ratio of v1 and v2 will be equal to 1 minus e by 1 plus e agutte. Clear? Let's see the numerical, how the questions will be asked based on this. So my dear students, if the question to be asked in inelastic collision, especially semi-inelastic collision, ee concept mele question barabodu. Listen, ee concept mele barabodu. So let's look at the question here. How simple, nodri question. So there is the ground, a body of mass m, and this is also a body of mass m. So initially the body is moving with the speed u1 and the second body is a restum. Alright? Given after the collision, given after the collision, final velocity of the second body is equal to 2 times the final velocity of the first body. You understand? After the collision, nodri, after the collision, this is first body, this is second body. First body is moving with a velocity v1 and the second body is moving with a velocity v2. This second body speed is 2 times of the first body speed after the collision. Right? It's quite interesting question. Find the coefficient of restitution. No. So in case nodidre, immediately you should understand this is, see they are talking about the coefficient of restitution. Coefficient of restitution gottilla andre what kind of collision they are talking about. They are talking about the semi-inelastic collision, my dear students. Okay, and this is the semi-inelastic collision. And in case nodidre, we must remember v1 by v2 is equal to 1 minus e by 1 plus e. And v1 by v2, what is v1 here? Okay, as it is v1 I will write v2 is 2 times v1 which is equal to 1 minus e by 1 plus e. v1 cancel and 1 by 2 is equal to 1 minus e by 1 plus e. So just cross multiplication, 1 plus e is equal to 2 minus 2e. Okay, and this is e plus 2e. 3e kade irutte and 2 is as it is, and this 1 comes to the other side, that will be 2 minus 1 and that's 1. So e is equal to 1 by 3. 1 by 3. Is it between 0 and 1? Is it the value is lying between 0 and 1? Yes, 100% that's correct. If you got the e value is negative, and that's a wrong answer. And if you get your e value greater than 1, and that is also the wrong answer, because semi-inelastic collision alli e value lies between 0 and 1, my dear students. Alright? So this is how semi-inelastic collision will be discussed. Right? And And there are some more models of questions will be available based on semi-inelastic. Once we finish this perfectly inelastic collisions, then we'll discuss some numericals also related to the semi-inelastic collisions now. Okay, my dear students, before we move into the perfectly inelastic collision, we should talk about in a semi-inelastic collisions, we must talk about loss of kinetic energy. What is the topic here? Loss of kinetic energy. What I have told you, loss of kinetic energy, it's a half m1 u1 square plus half m2 u2 square, that is the initial kinetic energy of the system, minus half m1 v1 square plus half m2 v2 square. So this is the final kinetic energy of the system. If v1 and v2 place ali, just now we have got some expressions, right, for the final velocities. Our final velocity expressions illi substitute madidre, you will get an expression, a loss of kinetic energy, which is denoted with the symbol delta Ke is equal to half into m1 m2 by m1 plus m2 into 1 minus e square into u1 minus u2 whole square. Don't be afraid by looking at this expression. ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಡಿರೈವ್ ಮಾಡಬಹುದು. ಇಟ್ ಇಸ್ ಸೋ ಸಿಂಪಲ್. ಇಲ್ಲಿ v1 and v2 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ನಿಮಗೆ ಬರುತ್ತೆ, ಬಟ್ ಇಟ್ಸ್ ನಾಟ್ ರಿಕ್ವೈರ್ಡ್ ರೈಟ್ ನೌ. ನಿಮಗೆ ಬೇಕಂದ್ರೆ ನೀವು ಟ್ರೈ ಮಾಡಬಹುದು, ರೈಟ್, ಬಟ್ ಇಟ್ ಟೇಕ್ಸ್ ಲಾಟ್ ಆಫ್ ಟೈಮ್. ಸೊ ದಟ್ ಇಸ್ ದ ರೀಸನ್ ಐ ಹ್ಯಾವ್ ಜಸ್ಟ್ ಡೈರೆಕ್ಟ್ಲಿ ಗಿವನ್ an expression here. Change in kinetic energy is equal to half into m1 m2 by m1 plus m2 into 1 minus e square into u1 minus u2 whole square, my dear students. Okay, clear for everyone? This is the loss of kinetic energy expression. Careful agi observe madri. For elastic collisions amma, for elastic collisions, we have concluded previously loss of kinetic energy is 0 anta conclude madidvi. Yake 0 barutte nodri. For elastic collisions, E value 1 tane. When you substitute this E value 1 in this expression, ಏನಾಗುತ್ತೆ? E value ಇಲ್ಲಿ 1 substitute ಮಾಡಿದ್ರೆ 1 minus 1 0 ಆಗುತ್ತೆ. 0 into everything becomes 0. Understand? So when you substitute this E is equal to 1 in this expression, this complete expression will become 0. So that is the reason elastic collisions ಅಲ್ಲಿ loss of kinetic energy 0 ಇರುತ್ತೆ. Inelastic collision ನಲ್ಲಿ there is a loss of kinetic energy irutte. So generally we observe the collisions around us between two vehicles. Yesterday I have told you. So between two vehicles and between two carom coins, so two billiard balls. So those collisions all are the examples for your inelastic collisions, right? Now coming back to we'll solve some numericals also on this, right? Don't worry. So a perfectly inelastic collision. Perfectly inelastic collision. So that's the topic now. Perfectly inelastic collisions. Perfectly inelastic collisions are very, 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 very important because there is a case called a ballistic pendulum is involved here. So ballistic pendulum anta one case irutte illi. You might expect a question in your NEET exam, JEE, CET exams from this application. So this is the application is based on the perfectly inelastic collisions. ಈ perfectly inelastic collisions ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, listen. So this is what the ground, a body of mass m1 moving with a velocity u1. So there is a body of mass m2 moving with a velocity u2. And after the collision ಏನಾಗ್ತಾ ಇದೆ ಅಂದ್ರೆ, both the bodies are sticking together and moving with a common velocity v ಅಂತ. And that V, it's called as a common velocity, my dear students. So this V is equal to a common velocity. And you can write by using law of conservation of linear momentum, m1u1 plus m2u2 is equal to m1 plus m2 into v. And the expression for the common velocity, look at here, it's m1u1 plus m2u2 divided by m1 plus m2. So this is an expression for the common velocity, my dear students. And this is the common velocity case we have already discussed in Newton's laws of motion. I hope you remember it. Now, after this, two things I just wanted to tell you. Two things. Listen, two things. Number one, collision can also take place when two bodies are moving towards each other. Aa case alli collision agutte. Even in that case also, both the bodies stick together and can move with a common velocity. Adu agutte. So 2 points I just wanted to tell you, my dear students. Number one, the collision can also take place when two bodies are moving towards each other. And in that case also both can stick together and move with common velocity. Okay. Now, ಈಗ ನೀವು ಚೆನ್ನಾಗಿ ನೋಡಿದ್ರೆ, so here imagine u1 is in this direction, u2 ಈ direction ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ರು ಅನ್ಕೊಳ್ಳಿ. If u2 is given in this direction, u2 need to be taken as negative. And here also this u2 need to be taken as negative. And listen, the second point is coming back to the laws of kinetic energy. Yakandre, ee perfectly inelastic collision also there is a loss of kinetic energy. See here, I am writing here. So there is a loss of kinetic energy existing perfectly inelastic collision, and the formula remains exactly the same. The formula remains same. Loss of kinetic energy is equal to half m1 m2 by m1 plus m2 into 1 minus e square into u1 minus u2 whole square. Sir, ಈ ಪರ್ಫೆಕ್ಟ್ಲಿ ಇನ್ಎಲಾಸ್ಟಿಕ್ collision ಅಲ್ಲಿ ನಮ್ಗೆ ಗೊತ್ತು ಸರ್ ಅದು ಝೀರೋ, ಈಗ ಝೀರೋ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀನಿ ಸರ್ ಅಂದ್ರೆ ಮಾಡ್ರಿ, ದಟ್ಸ್ ಕರೆಕ್ಟ್. So a loss of kinetic energy is equal to half m1 m2 by m1 plus m2, 1 minus 0 andre it's 1 into u1 minus u2 whole square. So this is the perfectly inelastic collision alli loss of kinetic energy formula. And the second point I am telling you, we are discussing the second point, my dear students. Our second point enandre, even if second body is coming like this, when the first body is moving like this and the second body is coming like this, right? In case alli this u2 need to be taken as minus. So finally enagutte, u1 minus of minus u2 agutte. Understand? So you should not miss that. And it's a common velocity expression, and this is loss of kinetic energy expression. Alright? Now, here, so what I just wanted to tell you is m1, one body moving with the velocity u1, in the m2 which is at rest at there. Good, which is at rest. After the collision, both the bodies are sticking together and moving with a common velocity v. Alright? Now, what I am doing is, initial kinetic energy estimated half m1 u1 square tane. What is the final kinetic energy here? So final kinetic energy is equal to half into final kinetic energy of the system, half into m1 plus m2 into v square. That's a common velocity square. Okay, that is a common velocity square. Right? Now, observe carefully. So there is a loss of kinetic energy here. So the loss of kinetic energy here is kinetic energy initial minus kinetic energy final. Kinetic energy initial half m1 u1 square minus final kinetic energy is half into m1 plus m2 into v square. What is v square? So this is the common velocity. So the common velocity formula ಏನು ಆ ಕೇಸಲ್ಲಿ common velocity ಏನು, right? ಈ ಕೇಸಲ್ಲಿ common velocity ಏನಾಗುತ್ತೆ? Common velocity is equal to m1 u1 by m1 plus m2 ಆಗುತ್ತೆ. Understand? See, common velocity u2 0 ತಾನೆ, u2 0 ತಾನೆ. What is at rest? So m1 u1 by m1 plus m2 ಆಗುತ್ತೆ. So the same thing you should write here. So this is m1 u1 by m1 plus m2 whole square. Alright? So what I can write? So delta kinetic energy is equal to half m1 u1 square minus, so ಇಲ್ಲಿ ಒಂದು m1 plus m2 and here one m1 plus m2 cancel. So what is remained? Half into m1 square u1 square by m1 plus m2 ಇದೆ. And this one delta kinetic energy is equal to half m1 u1 square you can take common, right? So that you will get it as half m1 u1 square is taken common, and that is 1 minus half m1. One m1 illide ಮತ್ತೆ u1 square is already taken common divided by m1 plus m2 ಇದೆ. So that is equal to half m1 u1 square into m1 plus m2 minus m1 divided by m1 plus m2. So here plus m1 minus m1 cancel. So change in kinetic energy, loss of kinetic energy in bantu namge andre half m1 u1 square divided by m2 by m1 plus m2. Alright, clear? So what is this? What is this? Half m1 m2 by m1 plus m2. Nodri, half m1 m2 by m1 plus m2 into u1 minus u2 whole square. u1 minus u2 whole square, u2 0 tane. So that is why we have got u1. Understand? u1 minus 0 whole square under u1 square. So we have got the loss of kinetic energy is the same. The question will be asked, what is the fraction of loss of kinetic energy anta kodtare. What is the fraction of loss of kinetic energy antanu kodtare. So I'm just removing this, my dear students. So the question is, what is the fraction of loss of kinetic energy? Let's get into the topic, right? So the question is, what is the fraction of loss of kinetic energy? Okay, so that is the concept. So that concept will be loss of kinetic energy by initial kinetic energy. So loss of kinetic energy ಏನು ಬಂತು ನಮಗೆ? half into m1 u1 square into m2 by m1 plus m2 ಅಂತ ಸಿಕ್ತು. So divided by what is the initial kinetic energy ಈ ಕೇಸಲ್ಲಿ? ಈ ಕೇಸಲ್ಲಿ initial kinetic energy is half m1 u1 square. Okay, before the collision. So this is half m1 u1 square. It will cancel. So fraction of loss of kinetic energy kelidre, simply you just do it like m2 by m1 plus m2. Idu gottidre, so you can easily find the fraction of loss of kinetic energy, right? All right, I hope you are following and understanding the class. Now, what I have just told you about a concept called a ballistic pendulum, so that we will discuss right now, my dear students. This will discuss. So, this is the concept you have already know. There is a wooden block of mass m is kept here. There is a wooden block of mass m. So there is a bullet of mass small m moving with a velocity u. and it is moving like this and striking this. Initially this is at rest, okay, and after striking it, this small mass is embedded into this wooden block. Andre wooden block inside hogitu, this M. The small bullet is went inside the wooden block and not coming out. And both wooden block and bullet moving with some velocity v. That's a common velocity v. Understand? So now the concept here, by applying law of conservation of linear momentum, according to law of conservation of linear momentum, so ಏನು ಮಾಡಬೇಕು ನಾವು ಅಂದ್ರೆ initially it's a MUM. Initially before the collision, initial linear momentum of first body idu plus second body initial linear momentum is 0 ತಾನೆ before the collision. After the collision ಏನಾಗ್ತಾ ಇದೆ, both the bodies are sticking together, so M plus M into a moving with a common velocity. ಈಗ common velocity formula ಸಿಕ್ತು ನಮಗೆ, M into U by capital M plus small m. ಇದು common velocity formula. ಈ ಕೇಸಲ್ಲಿ common velocity formula ಸಿಕ್ತು. Now, and in the same case, law of conservation of energy also can be applied. Law of conservation of energy can be applied. So when the bullet is striking it at this point, this point is the lowest point. The lowest point, the body will possess only the kinetic energy. So kinetic energy at lowest point is equal to potential energy at the highest point thane, by using law of conservation of energy. So kinetic energy is only possessed at the lowest point. There is no potential energy. And at the same time, when it reaches to the height h, from the reference point, when it is reaches to the height h, so the body will possess only the potential energy. After reaching here, it comes back. Okay. So kinetic energy at the lowest point, half into M. Here at the lowest point, both the bodies are there, bullet and the block, into V square. V square is the common velocity square, which is equal to potential energy at this point. So potential energy at this point is capital M plus small m into G into H. How much height the wooden block rises, you can find. Because E2 will get cancelled, and you have V square is equal to a 2GH, and V is equal to a root 2GH, and this common velocity you can also find by using this formula, root 2GH. Two types of questions can be asked here. Number one, common velocity ಎಷ್ಟು ಅಂತ ಕೇಳಬಹುದು, and number two, and this is at what height the body is raised ಅಂತನೂ ಕೇಳಬಹುದು. From here, height also they can ask, my dear students. Height also they can ask, right? Now, let us try to understand some more models related to this inelastic collision. So both perfectly inelastic and semi-inelastic. Idr mele kelavu questions nodona, right? After that, we'll conclude the concept of collisions, right? Including collisions in 2 dimensions in the next class, my dear students, right? So right now, we'll solve this numericals. Get ready for that. Listen to the questions here. A particle of mass m moving with a speed u collides perfectly inelastically with another particle of mass 2m. First mass m, it's moving with velocity u, and the second mass is at rest. Find the loss of kinetic energy. That may be the perfectly inelastic or semi-inelastic, whatever it may be, the loss of kinetic energy is equal to half into m1 m2 by m1 plus m2 into 1 minus e square into u1 minus u2 whole square. That's the formula. And ಈ ಕೇಸಲ್ಲಿ loss in kinetic energy ಏನು half into m1 it's m, m2 it's 2m divided by m plus 2m it's 3m into e 0 ಆಗುತ್ತೆ because perfectly inelastic collision e is 0 and 1 minus 0 it's 1 into u1 minus u2 ಅಂದ್ರೆ second body is at rest ಅಂತ ಕೊಟ್ಟಿದ್ರೆ clear. So u1 is u andre it is just u square. Now m 1m cancel. Okay, so here 2 also cancel. So loss of kinetic energy ಏನು ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ it's 1m ಇದೆ 1 by 3m u square ಆಗ್ತಾ ಇದೆ. That's the loss of kinetic energy. And at the same time, sometimes I've told you, right, the fraction of loss of kinetic energy antanu kelbodu. Fraction of a loss of kinetic energy antanu keltare. So that is what a loss of kinetic energy by initial kinetic energy. Loss of kinetic energy is 1 by 3 mu square by initial kinetic energy enamma half mu square because second body rest alli ide. So this is mu square cancel and 1 by 3 into 2 by 1 and it's 2 by 3. What is 2 by 3? This one. Delta Ke by initial kinetic energy. A loss of kinetic energy by initial kinetic energy. That's what? Fraction of loss of kinetic energy, my dear students. Clear? Now, coming back to this. One more point. So the same question can also be asked like this. Let's see the another example. There is a mass of 5 kg is given. Observe. Mass of the body is given as 5 kg. And initial velocity of this body is 8 meter per second, my dear students. Now, the second mass, this is first mass. Second mass is given as 15 kg and the initially it is rest. In case what is the loss of kinetic energy? That's my question now for you. Everybody should do this and tell me the answer. Loss of kinetic energy is 2. Second body is at rest and we are talking about the same perfectly inelastic collision only. Same question, what is the loss of kinetic energy? Pause the video, answer me in WhatsApp. Okay, now, here example note. There is a body of mass m and same body of mass m. Both bodies are moving towards each other. One is moving with 20 meter per second, another one is moving with 25 meter per second. After the collision, it's clearly mentioned that they are moving sticking together. What is that common velocity? I have told you the formula. Did you remember? Common velocity generally m1 u1 plus m2 u2 divided by m1 plus m2 anta barutte. But here, as this velocity is negative because one velocity positive tagondidre, the other one must be considered as negative and this will be negative. Or let's substitute the values also, there's no problem. So m into 20 minus m into 25 divided by m1 plus m2, that's 2m. Understand? So we'll get the final answer. So what is that? So m, if you take common, 20 minus 25, it's minus 5. So divided by, so what is that? It's 2m. mm gets cancelled and the answer is minus 2.5 meter per second. Andre minus direction enuma. This is the minus direction. Minus direction is indicating this velocity direction tane. Andre after sticking together, the bodies will move in this direction, in the minus direction anta meaning idu. Idu common velocity direction anta. That is why we have got minus 2.5 meter per second. There is a body of mass m moving with initial velocity u. There is another identical mass, and there is same mass which is at rest. ಈ ಕೇಸಲ್ಲಿ coefficient of restitution ಕೊಟ್ಟಿದ್ರು 1/2 and what kind of collision it is? Elastic, inelastic, semi-inelastic, perfectly inelastic. It is exactly speaking semi-inelastic collision. That's why it is given as 1/2. ಈ ಕೇಸಲ್ಲಿ ನಿಮಗೆ ನೆನಪಿರಬೇಕು, ನೆನಪಿದೆ ಅಂತ ನಾನು ಅನ್ಕೊಂತಾ ಇದ್ದೀನಿ. ಸೊ 2 identical masses are there. One is moving with initial velocity u, the other one is at rest. ಈ ಕೇಸಲ್ಲಿ v1 by v2 is equal to 1 minus e by 1 plus e ಅಂತ ನಾವು ಡಿರೈವ್ ಮಾಡಿದ್ವಿ. ತುಂಬಾ ಪ್ರಾಕ್ಟೀಸ್, ಜಾಸ್ತಿ ಪ್ರಾಕ್ಟೀಸ್ ಇರಬೇಕು to understand and to recollect all these formulas. So e value 1/2 anta kottidru. So here v1 by v2 bekandre it's 1 minus 1/2 by 1 plus 1/2. Now 1 minus 1/2 andre 1/2, idu 3/2, and we get v1 by v2 is equal to 1/2 into 2/3. It's 1/3. That is the answer, right? And you can also use the componendo and dividendo rule also, my dear students. And this is how inelastic collisions will be discussed, and numericals also. There are some more numericals are available that will be covered in assignments and exams, and any doubts you can at any time you can WhatsApp me, right? All the very best for your assignment and the evening test. Hope everybody is safe and sound, and take care. Bye bye. Shining off. See you in the next class.